Hi everybody, we're going to work on linear functions now. This is one of the easier topics in the course, but it does probably have the most amount of content because we've been covering it since year 7. Now, it starts with a situation, as is common with most of the chapters. We have 3 electricians, Sparky, Voltman and Flash, and their charge rates are graphed on the graph here on the right hand side. But we're not told which is which, so we have to figure it out. Now, each charge rate has 2 components, the fixed rate, which gets charged regardless, and an hourly rate. The fixed rate is represented by where it crosses the y-axis. The hourly rate is represented by the slope of the curve. So let's see what I mean by that. Well, Sparky has no standing charge, so he crosses the y-axis at 0. Voltman has the highest standing charge, so it's going to be this line here, and it crosses the y-axis at 120, so his standing charge is 120. Flash is the remaining electrician, so it will be this grey line here. And he has a standing charge of 80. Now, Sparky charges the most per hour, so we would expect Sparky to have the greatest slope. Here's Sparky, and we can see that his line is the steepest and increases the most. Now, the question asks us to find the equation of each line. So, and we've been given the first one for Voltman for this line here. It's 60t plus 120. And in fact, though I've put y here, it would be c for cost. And this axis here would be c. And this axis here would be time. Now, we could do the same for these two. Now, if we're looking for line 2, which is the grey line here, as we know, it crosses at 80, so that gives us the last part of the equation. We need to work out the slope. It's going across 1 unit. It goes from 80 up to 180, so the rise is 100. 100 over 1 gives us a slope of 100, and we can then put that into the equation. There's the equation for Flash. We can do the same for Sparky. Sparky goes from 0, 0 to 1, 120. That's this point here. I'll mark it on here. So the run is 1, the rise is 120, giving us a slope of 120. There's no standing cost, so plus 0, which gives us an equation of c equals 120t. Now it asks us which one should we use for varying time limits. So if the time that it takes to complete the job is between 0 and 2 hours, we're best to use Sparky because he costs the least. If it's between 2 hours and 5 hours, we're best to use Voltman because he costs the least. We're never really in a place where we can use Flash because he's always more expensive than the other Sparkies that are available. And that's the gist of the first question and the situation. As always, it's best to attempt these situations before looking at how I solve them, but I know many of you will just sit and watch the video. So let's get into linear functions. A linear function typically is in the form y equals mx plus c. We call that slope-intercept form because it has a slope component and it has a y-intercept component. When we graph this, we will get a straight line. All graphs in this form, whether it be y equals 2x plus 5 or y equals negative x plus 3 or anything in that form, will make a straight line. The slope of the line can be found using rise over run. So if we take 2 points on the line, calculate the rise between the 2 points and how far it's going to cross, that will tell us the slope of the line. The y-intercept is where it crosses the y-axis. So in this case, it's crossed it at 0, 1. When we look at a difference table, and a difference table is defined by having the x values increase by 1 and listing the corresponding y values for each x value, and then working out the difference between the y values. So the difference between this y value and this value is 1. It goes up by 1, it goes up by 1, it goes up by 1. We can find this value by subtracting. 2 take 1 will give me 1, 3 take 2 will give me 1, 4 take 3 will give me 1. When this first difference, these values here, are constant, we know we have a linear equation. And to find the equation, we use values in the table to get an equation in this form here, generally with a value there and a value there. So I'm just going down a bit to see if we actually calculate one, or if I should go through it now. I should probably go through it now. So this difference table has some interesting information in it. The gradient is always here, so our m value will be 1 in the case of this table, and our y-intercept is here, so it's going to cross the y-axis at 1. The equation for this table would be y equals 1x plus 1, or just y equals x plus 1. It's this graph here. Alright, let's have a look at some examples. So, if we were given a coordinate 0, 5, and the gradient was 7, we could find the equation of the line. We substitute y in where y goes for y equals mx plus c. We substitute 0 in for where x goes in y equals mx plus c. We substitute 7 for where m is 7, and we're looking for c. If we solve this equation, 5 equals 7 times 0 plus c. C would have to be 5, and the equation of a line that passes through 0, 5 and has a gradient of 7 would be y equals 7x plus 5. And that should be relatively simple to you by now. If it's not, you have some revision to do. Example 2, we have an equation y equals 3x take 5. Find the gradient and the y-intercept. Well, the gradient's 3, the y-intercept will be 0, negative 5. Example 3, we have an equation that's not in slope-intercept form. So if we want to know the slope and the y-intercept, the first thing we should do is rearrange it. So over here, we've taken 3x from both sides and then divided both sides by 5. And then rearranged it to have the x value first and the y-intercept value second, which gives us a gradient of negative 3/5 and a y-intercept of 0, 4. Negative 3/5, 0, 4. For example 4, we want to determine if this coordinate is on this line. If that's true, after substitution, the left-hand side of the equation should equal the right-hand side of the equation. Or the substituted value should equal this value here. I think we're using the substituted value method in this case. So I'm going to put in negative 2. I'm expecting an answer of 8. I stick negative 2 in here, I simplify, I get negative 8 instead of 8, indicating that this point is not on the line. Direct proportion is a specific example of a linear equation. It's a line that passes through 0, 0. So it'll have the rule in the form of y equals kx. If I put the value of 0 on here, for any direct proportion question, it will pass through 0, 0. Now we can find the value of k simply by finding the first difference. And we'll note that in each of these cases, these will be a proportion of k, and the difference will always be k. Now once you've gone through all of that, you'll be able to do exercise 4a, and I'd encourage you to do that now, but if you want to hang in there for a second, I'll just talk about some of the things that your CAS calculator can do. Graph and table mode is a good way to display a graph. You put the equation into the equation table, and if you press this button here, it will graph it for you underneath. This button over here will set the axis up for you. If you're looking for a particular value within the table, you can use the gsolve function to find corresponding y values and where they cross the y-intercept and all sorts of things, and I'd encourage you to have a fiddle with that. We'll go into it in more detail later. You can create a table of values with this table button over here and the corresponding button that sets the range for it. The domain and range buttons are there. The one to the right is for the table, the one to the left is for the graph. And that's all that we have to do. We'll do lots of this graphing stuff over the next couple of exercises. So if you're not familiar with it, we'll have a good chance to have a play. Thanks, everyone.